All right, so we are going to be going over number 10 and 11 from 5.3. But you need some context. So here's our context. So this is a picture of the Washington Monument in Washington, D.C., where if you look at it, it's a frustrum on the, like, this long part here is a frustrum, and the very top of it is a pyramid. Okay. So they walk you through how to find the surface area of the whole thing by first like chopping off the pyramid, and then they made you find the lengths of the sides and the altitude. And then so we found this length of the altitude by using this right triangle that's like in the cross section there. And so that this is a drawing of one of the faces of the pyramid. Then they wanted you to find each face of the pyramid, the area of that, which is just a triangle. So it's base times height divided by 2. So the base of it is 34.5. The height of it we found was 58.12 feet. And now the area of that is 1002.57 feet squared. Okay. Then they had us go through the frustrum. And if you look at a frustrum, the sides, they're called lateral. The lateral faces of the frustrum are trapezoids. The area of a trapezoid, don't worry, you don't need to memorize this because I'll let you look it up, is base 1 plus base 2 divided by 2 all times height. Okay, so base 1 times base 2 divided by 2 times your height. Okay, so I just plugged that in and I got the answer for one face was 22,375, but this asked you for all 4 faces. So then I just multiplied by 4 to get 89,500 feet squared. So imagine 89,500 tiny little Post-its covering this whole monument, right? Now it's telling me to find the, okay, so here's number 10. Find the total surface area of the Washington Monument. Well, that's just the frustrum, what I already found here, plus the pyramid, which is up here. And I already found one of the faces. So I'm going to have to go back and grab all 4 faces. So my formula is going to look like this. If I was to break it down, it'd be 4 of the trapezoids like this, plus 4 of the triangles like this is going to give you your total surface area. So hopefully you can kind of see that. Like if you were to walk around, I'm going to try to scroll up, but my mouse does not like scrolling up very quickly. So if you pretend that you walked around and you stood there and you're like, oh, if you wrapped this whole thing up, the frustrum and the pyramid on top with tiny little Post-its, they wanted to know how many Post-its would you have to use. Okay. So the 4 trapezoids I already got, it's 89,500 feet squared. And then 4 of the triangles. Now, this is just one of the triangles, each triangle. So I'm going to go plus 4 of the 1002.57 feet squared. So just so that you know, when you're adding things together, feet squared plus feet squared gives you more feet squared. Like this is back in kindergarten, right? Johnny has 2 apples. Then Susie gave him 4 more. How many apples does Johnny have now? I don't know why Johnny is collecting apples. Okay, that's my thing. That's my question. Johnny, what are you going to do with all these? Maybe Johnny's going to make apple pie. Do you ever think about that? Okay, sorry. So then I'm going to add these all together. So my answer is going to be in feet squared, which is a unit. And units are very good indicators whether you did something right. So 89,500 plus 4 times 1002.57 gives me 93,510 0.28 square feet. So I got to write that down. 93,510.28 feet squared, or square feet, whatever you want to call it. So can you imagine collecting 93,000, almost 94,000 little tiny Post-its? And I said, okay, now cover the monument. It would take a really long time, right? And hopefully those are pretty good stickies there. But this is what the answer is. Okay, so all you're going to do is break things down into their parts, and then it makes a lot more sense. Okay, so number 11 says, find the volume of the Washington Monument. So now they're asking for volume. Okay. And they give you both of the volume formulas, this and this. So all I have to do now is just plug in everybody to make sure that that's right. All right, so let's plug in. So the height of the frustrum, if you look up here, was 500, right? It's 500 feet. So it's going to be, I'm going to write it right next to it. So V equals to 1/3 of the height, which is 500 feet, times A squared, AB, B squared, where A and B are the side lengths of each square. Where A and B are the side lengths of each square. So here is going to be one of your bases, your A or your B, and it doesn't matter which one you choose. And then up here is going to be your other. Okay. And you could actually, if you don't want to use this formula, you could use a formula that we did, which was basically, we used it for a cone kind of, which was cone minus cone. Then this is the shortcut. So here, A and B, this is one side of the square base, and here's your other side of the square base. Okay, so I'm going to go with that, and I'm going to go, what was it, 55 and 34.5, is that right? Yeah, so it's going to be 55 squared plus 55 times 34.5 plus 34.5 squared. Oops, I missed the squared. Okay, and that's that formula, right? And then I'm going to find this other formula, which is 1/3. This L right here, this L, it's the slant height of your pyramid. I'll show you what that is in just a second. So I need my L, and it's going to be squared times my H. Okay, so I'm going to go up here to my pyramid. This blue line here, which is this blue line here, this is your slant height. So slant height, named appropriately, right? It's the slant height. It's the height of your pyramid at a slant. It sounds funny because we always think about height being like perpendicular. So this is the L that they're talking about. And so I'll label it here just so that you guys all have reference. This is the L that they're talking about. I labeled it A here because I didn't want to confuse you, but this is actually L. So this is my L, which is equal to L, which is equal to L. These are all my L's, okay? This is the same as this is the same as this. It's just different perspectives of your L. Your height is this guy right here. Your height is this guy right here, is your 55.5 feet. So this is your height of your pyramid, which is right here. So there's your two numbers, 55.5 and 58.12. Okay, so I'm going to plug that in over here. So this is, where is it? 58.12 goes in my L spot, and 55.5 feet. I wanted to put feet in there. And so then I'm just going to plug this all into my calculator, and then I'm done. Okay. So give me 1 second. So now I'm just going to plug this into my calculator as this plus this. I know there's students who like to do this thing where they do into this calculator anyway. I will enter all of it in once because this calculator will do PEMDAS for me. If the calculator that you're using doesn't do PEMDAS for you, then yes, enter it one at a time. But I'm going to scoot this over and show you that I can enter all of this in because my volume is going to be the volume of the frustrum plus the volume of the pyramid. And that's going to give me my total volume. Okay. So let's see, 1/3. And I'm just going to make sure that I type everything in correctly. And then it says 55 squared plus 55 times 34.5 plus 34.5 squared. Let's see if I did that correctly. Ms. Johnson needs to make sure. 55 squared plus 55 times 34.5 plus 34.5 squared plus 1/3 of 58.12 squared. Did I do that right? 1/3 of 58.12 squared times 55.5. So my total answer is, oh my gosh, let's count. 1,000,000 81,283.45 blah, blah, blah feet squared. So I'm going to add that together on my thing down here. I'm just going to do it like this, like a big O adding. And so my answer is the volume total equals to 1,081,283. I'm going to cut it off at 45 feet cubed. Okay. Where did you get feet cubed from, Miss Johnson? Well, I should have put feet in each of these. Let me squeeze that in so that you guys all see this. So this is going to be feet. This is feet. This is feet. This is feet. So feet squared plus feet times feet, which is feet squared times feet is feet squared. So this is feet squared in here. So all in here is feet squared. Well, feet squared times feet makes feet cubed, right? So this up here is feet cubed. Oh, you can't see. Sorry. So this up here is feet cubed. Feet squared is feet squared times feet is feet cubed. What's feet cubed plus feet cubed makes feet cubed. So here's your answer. Hopefully that makes sense. I'm sure it does. If not, let me know what questions you have. Do use units. Units are a really neat indicator of if and pointing you in the correct direction. For this slant height, I'm not sure if your teachers have ever used that term before. I'm just going to review it really quick just so you see it one more time. If you are getting confused on slant height, so if this is the pyramid in front of you, the slant height is laying slanted against your pyramid. You see it? He's right here. If I peel off this face, it's just the height of this face of this pyramid. Okay, so your slant height is different than your height. Your slant height is different than your height. Your slant height, as indicated, means that it's slanted. The height of your pyramid is just your regular height. Sometimes they call it the altitude, which is this right here, right? Planes fly at an altitude. If you've ever been on a plane, that's what the captain says. We are flying at an altitude of, it means if you dropped a really long rope from plane to the floor, that's the height of the plane. All right. Thanks for listening.